Okay, gentlemen, today we're looking at 7.2 day 2 using similar triangles to solve problems. Our learning goals are somewhat similar as last time. So the scale factor k relates the lengths of corresponding sides of similar figures, and the square of the scale factor, or k squared, relates the areas of two similar figures. So the first question gives us some information about Bridget. Her shadow coincides with the tip of the tree shadow, gives us her height, how long her shadow is, and how long the distance she stands from the tree. You may want to try and label this on your own and not looking too detailed at what I've done here already to see if you can label properly. Once you've done that, you can take a look here, of course, and see how I've labeled the diagram based on the information given in the question. And then what I've also done is I've gone ahead and drawn basically what the question tells us to do without the tree, without the Bridget and all that, so that you can see very clearly that all we really have is two similar right triangles. Okay, and the assumptions you can make in this question are right here. You can assume that Bridget is standing at 90 degrees to the ground, that she's standing straight and tall. And you can also assume, well, it's actually given in the diagram there in the bottom right. It's very faded, but you can see it shows us that that is a 90-degree angle. So Bridget makes a 90-degree angle with the ground, and the tree makes a 90-degree angle with the ground. So we know that those are both 90-degree angles. Okay. I've also labeled here, highlighted the question. So how tall is the tree? So that's why I labeled this area right here X. And on this diagram, that's why I've labeled it X here as well. So we want to know how tall the tree is. Step one, you want to prove similarity between the triangles, right? So we need proof because the question is asking us to justify our reasoning. So if I'm going to justify my reasoning, I'm going to first identify the triangles that are being compared. I've labeled them A, B, C, as you'll see here, A, B, and C. And then, of course, I labeled the smaller one D, E, C. Okay. And I think I made a little mistake here and just noticed quickly. I labeled that D, E, F, but it'll be D, E, C. So let's change that right now. Okay. So we know that these are the two triangles, A, B, C, and D, E, C. Those are the two. I can't write this yet that they're similar because we haven't proven the similarity. All I could do is identify the triangles. That's why I purposely used the word identify. So you don't have to write this when you're doing your work. All you'd have to show is this right here, ABC and triangle DEC, and then give me the proof, which is indicated right here. We need two sets of angles that are equal or congruent, or we have to prove that side lengths are in the same ratio. Because we're actually looking for a side length, we already know off the bat that we can't use side lengths in the same ratio as our proof. So very quickly and easily, and you've seen this in last day, angle C equal angle C because that's common to both, and angle B is equal to angle DEC, both 90 degrees. So we've got two 90-degree angles. We've got two 90-degree angles here and here, and then we both have angle C in common. Okay, so we do not need to prove, I've noted here, we do not need to prove that the third angle, prove the third angle, as it is assumed since all angles add to 180 degrees. So the third angle will be the same for both. They both have a 90-degree angle. They both share angle C. Obviously, the third angle will logically be the same degree for both. So step two says identify the triangles that are similar. So be sure to line them up so that congruent angles are one on top of the other. This will ensure that side lengths line up for the next step. So now we've proven, because of the proof in step one, we can now say that triangle ABC is similar to triangle DEC. And I know angle B is 90 and angle E is 90. We've got that here in our diagram. So that's why those line up. Obviously, angle C will line up with angle C, and then we're left with A and D lining up one on top of the other. Now step three says place side lengths into ratios. So now we're going to do what we've done in the previous lesson. AB is in relation to DE, and then we know that, as I showed you in last lesson, that now we'll have BC over EC, and then of course you do the first and the last, which would be AC over DC. And now we have AC DC. That was somewhat Not planned. All right, step 4, solve for the unknown variable by cross multiplying. Well, first we're going to input into ratios here. We're going to input what we know. So line AB is the unknown. So we can label that X, and DE, let's just take a look at DE, we know is 1.5 meters. I don't write meters here. We'll do that in the answer. Is equal to, and what is BC? The entire length of BC is 6 plus 2.3. So altogether, the length of BC is actually 8.3. And that's a common mistake. Students forget to write that. So keep that in mind. And then we have EC, which of course is only 2.3, which is equal to AC. We don't know what AC is, and we don't know what DC is. So I'm actually just going to write AC, DC. And that's not to worry, because really all we care about is solving for x, and we can do that by cross multiplication right here. So we're going to end up with 2.3x equal 1.5 times 8.3. And then we're going to divide both sides by, first multiply 1.5 times 8.3, and we get 12.45, and this is 2.3x. If you divide both sides by 2.3, we end up with, I'll just write it up, let me just bring it up here, x equal, divided by 2.3 will equal approximately 5.4 meters. Okay, and I want to look at the next question with you as well, and that one is going to be one that you're going to do on your own. I do want to give you one quick hint though. It asks us to find the length of side DF and show your work. Given that this is given to you, that triangle ABC is similar to triangle DEF, so you don't have to prove that these two triangles are similar, but you'll notice that they're not labeled. So you may be wondering, was this a mistake? It's not a mistake. The question is saying to you, find the length of side DF. And you'll notice in the diagram, the only unknown is X right now. So you know that that has to be D and F, or it could be the reverse. You may want to write D here and F here, but either way, that length of that line has to be, or that line has to be labeled DF. Then you're given in the question that this angle equal this angle is obviously equal to that angle. So proving similarity should be fairly simple for you, but I'll go ahead and leave that to you. And that's the question that we'll take up together in the class, but I'm expecting you to have work done on your own. There are many parts here, so there are 3 parts. You're finding the side length of DF. Then you're going to find the scale factor. What is the scale factor? How do the triangles relate? So for example, if I have a triangle, how does that triangle relate? If this is 2 and this is 4, then I would say 4 divided by 2 equal 2. And so in order to go from this triangle to that triangle, I know that everything is 2 times bigger. So if I knew the side length were 3, then I would multiply by the scale factor, which is 2, and then that would be 6, right? Obviously, and if this is 1, I multiply by 2, and that would be 2, okay? And that asks us if the area of triangle ABC is 8 square centimeters, that's the larger triangle, then find the area of triangle, sorry, that's the smaller triangle, find the area of DEF. And I've given you the formula here. Area of larger triangle is the area of the smaller triangle times the scale factor squared. You'll remember that wasn't a learning goal from last lesson. And what I've done for you as well is down here, just as a little review, I'm just proving that learning goal. Why is the larger triangle times scale factor squared? Well, if you look at, you have the red triangle ABC, the area of a triangle is base times height divided by 2, as I indicated here. But then in this triangle, in the second triangle, you have base times height, but I've multiplied the base times k and the height times k because they are increased by the scale factor. They're that much bigger. And so then when we multiply kb times kh, you end up with k squared times bh, or, and I've highlighted it here for you, that the only difference then is the scale factor squared, because you're going to end up multiplying k times k. So that just proves why the learning goal is true, or why that works. And I know some of you are interested in knowing some proof there. So that's that. And I'll see you in class with the rest of that done. Take care.